Okay, take this problem. Okay, if f vector is equal to x plus y plus nabla square r to the power of n is equal to n into n plus 1 into r to the power of n minus 2. Okay. Here nabla square r to the power of n is equal to n into n plus 1 r to the power of n minus 2 we have to show. Okay. Then nabla square r to the power of n we are writing summation of del square by del x square. We can write no. What is a nabla square? Nabla square is nothing but del by del x square I plus del square by del y square j plus del square by del z square k. Okay. Then we are writing this is in this one we have to write in short form summation of del square by del x square. Okay. Then nabla square we are writing summation of del square. I am audible, no, Karthik?
Yes, ma'am, you're audible.
Okay. Yeah, notes also visible.
Yes, ma'am.
Okay. Nabla square we are writing summation of del square by del x square. Okay. Then r to the power of n. Then summation of del square by del x square we are writing del by del x into del by del x. Okay. Then r to the power of n. The next step, differentiate summation of del by del x. Differentiation of r to the power of n is what? N into r to the power of n minus 1 into del r by del x. Okay, del r by del x. Then summation of del by del x. Then n into r to the power of n minus 1. Previous class I told no what is the del r by del x. Del r by del x previous problem. Del r by del x is nothing but here x by r. Okay, x by r. Okay. Previous problem r vector we are writing square root of x square plus y square plus z square. Then r square is nothing but x square plus y square plus z square. Okay, here r vector is nothing but r vector is modulus of r vector is nothing but square root of x square plus y square. Previous problem I gave this and all. Okay, nothing but r square. R square is equal to x square plus y square plus z square. Then del r by del x. We are writing 2x by here 2r del r by del x. We are writing 2x. 2 get cancelled. Del r by del x is equal to 2. Okay. Then summation of del by del x. Okay, n into means in place of del r by del x we are writing x by r. Okay, means r is shifted to numerator. What will happen? R to the power of n minus 2. Okay, r is shifted to numerator. It will become r to the power of minus 1. R to the power of n minus 1 minus 1. We are writing r to the power of n minus 2 into x. Okay. Then next step, okay, next here, take down n outside of the summation and r to the power of n minus 2. This one, summation of xi we are writing. Okay, it will continue, summation of xi. Okay, next step here, take down n outside. Again, partially differentiating with respect to r. Okay, summation, then r to the power of n minus 2. Okay, del by del x. R to the power of, here we have to apply the product rule here. R to the power of n minus 2, write down as it is. Partially differentiating with respect to x means it is 1, then minus. Okay. Then x write down as it is. Again differentiation. R to the power of n minus 2 differentiate n minus 2 into r to the power of n minus 3 into del r by del x. Del r by del x. Okay. Then next n into summation of r to the power of n minus 2 into minus. Okay. Here plus, no, plus, then x by x into n minus 2 into r to the power of n minus 2, del r by del x, we are writing x. Okay, understood? I want to explain again in this problem. Harshita, yes. Amrita, yes. Amrita.
Yes, ma'am. 1 second, ma'am.
Observe here. Del nabla square r to the power of n. Okay. Then nabla square, we are writing del square by del x square I plus del square by del y square j plus del square by del z square k is equal to summation of del square by del x square. Okay, here nabla square, we are writing summation of del square by del x square. Okay, into r to the power of n, into r to the power of n. Okay, next step, what we have to do means write down summation del square by del x square. We are writing del by del x, del by del x. Okay, r to the power of n. Then summation del by del x. Observe here this one. Partially differentiating with respect to x here. Del by del x, r to the power of n. Partially differentiating with respect to x means n into r to the power of n minus 1. Okay. Then del r by del x. Del r by del x. Okay. Previous Saturday we already solved one problem. R vector, modulus of R vector, we are writing square root of x square plus y square plus z square. R square is x square plus y square plus z square. Then differentiate. Del r by del x is x by r. Del r by del y is y by r. Del r by del z is z by r. Okay. Means summation of del r by del x n into r to the power of n minus 1. Del r by del x, substitute here x by r. Okay. Summation of del by del x. Okay. N r to the power of, observe here this r shifted to numerator. I will write here one more step. Summation of del by del x n into r to the power of n minus 1. R is shifted to numerator, it will become r to the power of minus 1 into x. Okay, summation of del by del x n into r to the power of n minus 1 into r to the power of minus 1. We are writing r to the power of n minus 2 into x. Okay, again we have to differentiate here. Again, okay, del by del x. Okay, here we have to apply the product rule, r to the power of n minus 2 into x. Okay, n into summation of r to the power of n minus 2, write down as it is here. Then differentiation of x is 1. plus x write down as it is, then differentiation of r to the power of n minus 2. Differentiation of r to the power of n minus 2 means n minus 2 into r to the power of n minus 3. Differentiation of r to the power of n minus 2 is what? N minus 2 into r to the power of n minus 3 into del r by del x. Okay, and then n into summation of r to the power of n minus 2 plus x n minus 2 r to the power of n minus 3 del r by del x is what? X by r. X by r. Understood? Any doubt in this one?
Yes, ma'am.
Then write down here n is equal to summation of r to the power of n minus 2 plus x into x square n minus 2 into r to the power of n minus 3 x into x is x square. Okay, here r minus 1 differentiate what will get. This is okay. Here r, this r shifted to numerator, what will happen? R to the power of minus 1. X by r, x into x, x square, then r is shifted to numerator, it will become minus 1. Then n into summation of r to the power of n minus 2 plus n minus 2 r to the power of n minus 4 x square. Okay, then expand it. Expand it here, n into summation of r to the power of n minus 2. We are not writing summation here, we are expanding. R to the power of n minus 2 plus n minus 2 r to the power of n minus 4 x square. The next to r to the power of n minus 2 plus n minus 2 r to the power of n minus 4 into y square. Okay. Then plus r to the power of n minus 2 plus n minus 2 r to the power of n minus 4 into z square. Okay. Observe here the summation of r to the power of n minus 2 plus n minus 2 r to the power of n minus 4 x square. Expand it. R to the power of n minus 2 plus n minus 2 r to the power of n minus 4 x square. Similarly write down y square and similarly write down z square. Then what will happen here? R to the power of n minus 2 1, r to the power of n minus 2 2, then r to the power of n minus 3. Here 1 2 3 we are writing 3 r to the power of n minus 2. Okay. Then here observe here n minus 2 r to the power of n minus 4. Then here also observe here n minus 2 r to the power of n minus 4 y square. Here also n minus 2 r to the power of n minus 4 z square. Okay. Then in these three terms, we have to take n minus 2 r to the power of n minus 4 common. Observe here n minus 2 r to the power of n minus 4 and n minus 2 r to the power of n minus 4. N minus 2 r to the power of n minus 4, take down common here, n minus 2 r to the power of n minus 4, then remaining here x square plus y square plus z square. Okay, then n into
Ma'am, it's r to the power of 4. R to the power of n minus 4.
Okay, 3 r to the power of n minus 2 plus n minus 2 r to the power of n minus 4. This we are writing x square plus y square plus z square. We are writing r square. Okay, we are writing r square. Then n into 3r to the power of n minus 2 plus n minus 2 r to the power of n minus 4 plus 2. Okay. Then n into 3r to the power of n minus 2 plus n minus 2 into r to the power of n minus 2. Then we can take again r to the power of n minus 2 common. Remaining is here 3 plus n minus 2. Then simplify n into r to the power of n minus 2 n plus 1. Okay, this is we have to prove n into n plus 1 r to the power of n minus 2. Okay, this is required answer. Understood? Write down one by one. I will give 2 minutes. Write down. Then I will start solenoidal and irrotational methods.
From final step.
Final step. All of them. Completed. Completed.
Yes, ma'am.
Yes, ma'am.
Okay. Take these points, very important. Solenoidal. Next hour, you have which class?
CPS, ma'am.
I will send the notes. Okay, I will tell you now only which point you have to remember. Theory part I will send the notes in WhatsApp group. Okay. Yes, divergence of a vector F vector is a solenoidal. Okay, a vector F vector is said to be a solenoidal. Divergence of F vector is 0. Okay. Okay, solenoidal means divergence of F vector is 0, means the given vector is solenoidal. Then curl of F vector. Curl of F vector is 0. Okay, we are call it as this is irrotational vector. Irrotational vector or conservative field or potential field. Okay, curl of F vector is 0 means irrotational vector irrotational vector field or conservative field or potential field Okay. Question no. Show that the given vector is solenoidal. Show that the given vector is irrotational vector field or conservative field or potential field. Okay. Then we have to find the scalar point function. Okay. We have to find the scalar point function. How to find means nabla of phi is equal to f vector. The given function is curl is a irrotational. Then next step we have to use this one. Nabla phi is equal to f vector. Okay. Then nabla phi means del by del x, del phi by del x I plus del phi by del y j plus del phi by del z k. Okay. F vector we are writing xi plus yj plus zk. Yj plus zk. Then we have to compare. Okay. Here we have to equate. Okay. Means equate of I and j and j and k and k. Okay. Here del phi by del x is equal to x we are taking. Then del phi by del y we are taking, y we are taking. Del phi by del z we are taking k. Okay. Then next step what we have to do means we have to do integrate. Okay. This is scalar point function. In scalar point function, this is also very important concept. Nabla phi is equal to f vector. Then equate I and j and j and z. Okay. Let's just equate the I part and j part and k part separately. Then del phi by del x is equal to x is given here. Means integrating with respect to x only we have to do here. Carefully observe here. Del phi by del x is equal to x is there. Okay. Means del phi by del x partially differentiating with respect to x is there. You have to integrate x only. Phi is equal to integration of x into dx. Okay. Come to second term. Del phi by del y is equal to y. Okay. Partially differentiating with respect to y is there. Means phi is equal to integrating with respect to y dy plus, here observe here I am adding c. In place of c I am adding here f1 of del phi by del x. Integrating with respect to x means y and z are constant term. Okay. In place of c, observe here in place of c I am writing f1 of y comma z. This concept understood now. Del phi by del x is equal to x. Integrating with respect to x we have to do here. Integration of x dx plus in place of c we have to write down f1 of y comma z. Y comma z is a constant term only. That's why in place of c we are writing f1 of y comma z. Then come to del phi by del y is equal to y. Okay. Del phi by del y is equal to y. Then phi is equal to integration of y dy plus in place of c we are writing f2 of partially differentiating with respect to y here is there. Means we have to write x and z constant term. In place of c we have to write f2 of x. Similarly here also del phi by z. Integrating del phi by del z. Del phi by del z means integrating with respect to z we are doing. Phi is equal to integration of, this is z dz plus f3 of x comma y. X comma y is a constant term. Then phi is equal to here x square by 2 plus f1 of y comma z. Then phi is equal to y square by 2 plus f2 of x comma z. then phi is equal to z square by 2 plus f3 of x comma y. Okay, this is very important concept. You have to remember here. Phi is equal to x square by 2. We observe Madi. We are getting three equations. Equation 1, equation 2, equation 3. These three equations we have to convert to only one equation. Okay. Then what we have to do means f1 of y comma z. We have to write y by 2 plus z square by 2. Okay, f1 of y comma z. We have to write down y square by 2 plus z square by 2. Then come to f2 of x comma z. We have to write x square by 2 plus z square by 2. Then f3 of x comma y. We have to write x square by 2 plus y square by 2. Then what will happen? All the equation become 1, 2, 3 and equation becoming a equal only. Means y is equal to x square by 2, y square by 2, then z square by 2. Okay, understood? Understood?